Hi, good morning. Time to do some science. So let's get started. Today I want to talk about energy. But where do I start? Energy is such a huge topic. We could talk about energy in the ecosystem and how energy flows from one organism to another one. We can talk about potential and kinetic energy. We can talk about so many things like forms of energy and different types of renewable energy sources. But I think we should start with our standard. All right, so let's start here at our energy overview. And let's scroll down to energy standards. And let's look at the second one, SCI HS-PS3-2. Develop and use models to illustrate that energy at the macroscopic scale can be accounted for as a combination of energy associated with the motions of particles and energy associated with the relative position of particles. Now that's a lot. So how do we unravel all of this? Well, I guess the first thing we need to remember is, what is energy? Well, if you recall, energy is the ability to do work or cause change. Do you necessarily have to be doing something at that time? No, you can store that energy. And if it's stored, it's called potential energy. If it's actively working, it's kinetic energy. Next, we also have to recall the difference between macro and micro. So remember, whenever we talk about macroscopic, that means easily seen by the naked eye. When we talk about microscopic, that's too little for our eyes to see. Things like atoms and molecules, things of that nature. Also, let me remind you, when we look at this word particles, it's P-A-R-T, and I would underline that, I-C-L-E-S. Particles, meaning to be a small, tiny little piece of something. The particles that we refer to at this level would be atoms and molecules. Okay, now it says develop and use models to illustrate. All right, so let's do that. Often when we think about temperature, we think about how hot or how cold something is. However, temperature is actually related to how much energy the particles have as they move around. So as you can see in the first picture, there's a little bit of particle motion, and there is a temperature, but it's a pretty low temperature. In the second picture, there's more particle motion, and as you can see, the temperature is higher than it was in the first. In the third picture, we have the most particle motion, which means we have a higher temperature. And that also means we have the most kinetic energy of the particles. Remember, kinetic energy is the energy related to motion. All right, so now we've looked at energy at a microscopic level. Let's see how that looks at a macroscopic level. All right, so as you can see here, this ice that is replaying, melting over and over again, we're seeing it at the macroscopic level where it just looks like, ice turns to water. However, what's happening at a microscopic level is those particles or those molecules are moving faster and they're moving further away from each other, which is what we see here. Not at the particulate level, but at the macroscopic level. All right, so now let's look at another example. All right, so here we have a situation with a balloon. We have a shirt, and we've done this in class where we've rubbed the balloon on our shirt and we got it to stick. And we observed that at a macroscopic scale or on a large scale where we can see it with our naked eye. However, what's occurring with the particles at a microscopic scale that makes this happen? What are these particles doing? Well, here I see in my balloon I have positive and I have negative charges. Let's rub it on the shirt. On the shirt, I have negative and positive charges, and they're just kind of evenly dispersed. So let's rub, 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 rub. Oh boy. Once I got to rubbing, I see that on this shirt sleeve, I have positive charges, and on the edge of this balloon that I'm rubbing, I have negative charges. And they attracted. So these positive particles are attracted to these negative particles. Hopefully, going through this lesson with me helped you get a better understanding of the energy associated with particles. It's been fun bringing you this lesson from home while you're at home too, and I'll see you very soon. Bye.